everyone. Welcome to this session. Today, we are covering two major areas in cybersecurity that are directly relevant to your daily life and to where the industry is heading. That is, mobile security and AI in cybersecurity. Almost everyone watching this is carrying a smartphone right now that holds a banking app, personal messages, photos, and location history. At the same time, the tools used to both attack and defend digital systems are increasingly powered by artificial intelligence. By the end of this video, you will understand how Android and iOS protect themselves, the threats mobile devices face every day, how apps get tested for security before release, and how AI is changing the way we detect and respond to cyber attacks. I'll also be running several live demonstrations along the way. We'll split this video into two halves. In the first half, we look at mobile security, that is covering Android security, iOS security, common mobile threats, and how mobile app testing works. In the second half, we shift to AI in cybersecurity, covering machine learning for threat detection, AI based security solutions, behavioral analytics, and where the field is heading with future trends. If you want to jump straight to a specific topic, check the timestamps. Let's start with mobile security. Your phone today does more than a desktop computer did 15 years ago. That is, it holds your identity, your money, and your conversations. That makes it one of the most attractive targets for attackers and one of the most important things to secure. On screen, just a second. Now just think about how many sensitive apps like banking, email, authentication apps you have installed on your own phones right now. That's exactly why this topic matters. Yes? Android security. Android is open source and runs on thousands of different devices, which gives it flexibility but also a larger attack surface. Let's go through its four key differences. First, app sandboxing. Every Android app runs in its own isolated space and cannot directly read another app's private files or memory. For example, WhatsApp cannot directly access Instagram's private data even though both apps are installed on the same phone. The Android sandbox keeps them separated at the operating system level. Second, Google Play Protect. This works like a built-in antivirus for the Play Store, continuously scanning apps for malware both before and after installation. If you have ever seen a warning like this app may be harmful to your device, that warning came from Play Protect. Third, the permission model. Since Android 6, apps must request permissions at the moment they are needed, not just once at install time. And you can deny individual permissions. A flashlight app asking for your contacts or precise location is a major red flag. It has no legitimate reason to need that data. Fourth, silliness enforcement. A kernel level policy layer that restricts what a process can do. Even if that process is compromised, this is one reason modern Android exploits often need to chain two or three vulnerabilities together just to fully take over a device. Now, the risks. Sideload. Installing apps from outside the Play Store, that is, skips Google's automated review entirely. Modified WhatsApp APKs from random websites have repeatedly been found bundled with spyware. Fragmentation means many budget devices stop receiving security updates after just a year or two, and routing gives full control but disables sandbox, which is why most banking apps refuse to run on a rooted phone. iOS security. iOS takes a much more locked down, closed approach. Let's look at its four key defenses. App sandboxing works similarly to Android. Every app is isolated from the OS and from other apps by default. The secure enclave is a physically separate security chip that stores extremely sensitive data. When you unlock your iPhone with Face ID, your facial map is processed and stored entirely inside the secure enclave. It never leaves that chip, and Apple itself cannot access it. Third, strict App Store review. It means every app goes through automated and human review before publishing. Apple has repeatedly caught and removed fleeceware apps that look like simple calculators or filters but quietly charge massive hidden subscription fees during this process. Next, mandatory code signing. It means only code cryptographically signed by Apple is allowed to run on the device. Now the risks. Jailbreaking removes the sandbox and code signing protections entirely. The closed ecosystem means users must place complete trust in Apple without visibility into how decisions are made, and even a fully updated iPhone can fall to a zero day. The Pegasus spyware used zero click exploits to infect iPhones without the victim clicking anything at all, targeting journalists and activists worldwide. Mobile threats. Regardless of whether a phone runs Android or iOS, it faces same broad categories of threats that are malware and trojans are fake or repackaged apps that steal data in the background. The Anubis banking trojan disguised itself as ordinary utility apps on the Play Store, then displayed a fake login screen over real banking apps to steal credentials, known as an overlay attack. Phishing and smishing are fraudulent messages designed to trick users into revealing credentials. The text saying your parcel delivery failed, click here to reschedule, that leads to a fake courier site asking for card details. That's smishing. Network attacks intercept traffic between a device and the internet, often over public Wi-Fi. An attacker sets up a hotspot named something like free airport Wi-Fi, and once you connect, unencrypted traffic can be intercepted before it reaches its destination. And data leakage happens when apps request excessive permissions or store data without encryption. Several popular apps have faced regulatory scrutiny for collecting far more data than their stated function requires. Mobile app test. Before an app reaches the Play Store or App Store, it should go through several layers of security tests. First, static analysis or SAST reviews the source code, reviews the source code or compiled binary without ever running the app. A tool like MobSF can scan an APK and immediately flag hard-coded API keys or passwords left in the code by mistake. Dynamic analysis or DAST tests the app while it's actually running using a tool like Burp Suite. A tester can intercept the app's network traffic while it runs and check whether sensitive data is being sent unencrypted. Second, Third, penetration testing simulates a real attacker's approach. WhatsApp bug bounty program once rewarded a researcher for finding a buffer overflow that could be triggered by a single missed call patched before it could be widely exploited. Fourth, the OWASP Mobile Top 10 is an industry standard checklist of the most common critical mobile vulnerabilities. That is, including insecure data storage and insecure authentication. Rule of thumb to remember is static analysis finds the flaw in the code, while dynamic analysis proves it can actually be exploited. Let's see both in action. Let's have a demo. We will be having a demo on Kali Linux system. So let's move over there. Switch to Kali Linux system. So here I have already installed Docker. You can see I have already run this command docker run itt for installing it, as it takes a lot time, and when you reach by this um, when you reach to this command listening at http 8004, you can switch to your browser and open this on localhost, and you will be seeing MobSF uh, dashboard. So let's go there. And yes, I have also downloaded the APK. Let me show you. Yes, so here you can see I have downloaded Insecure Bank V2 APK from this GitHub repository directly by typing this command. It also took a lot of time, so I just did it earlier. So it doesn't take much time right now. Okay, now let's see how it looks on our file explorer. So here we can drag and drop our file. So let's just upload. Um, yeah, so here you can see the security score. This is MobSF dashboard. Yes, you can see applications permissions. Let's scroll further. You can see various activities. You can see certificate analysis. This is manifest analysis, code analysis, file analysis, NIAP analysis. Yes, behavior analysis. This is how it looks like. Now, yeah, so here you can see. Everything file name, size, MD5 hash, SHA1, SHA256 hash, app name, package name, main activity, target SDK, minimum SDK, max SDK, Android version name, and everything. You can get each and every information. Yes. Now let's just view its code. Let's see. You can see we have got this code on. Now, none of this required running the app even once. MobSF pulled the app apart and read its code directly. This is exactly what a security team does before an app is approved for release. And it's surprising how often hard-coded secrets like this show up in real, yeah, or in published apps. So let's get back to our slide. This is how you can do it. Android versus iOS. Now, just let's have a quick recap. Android's strength is openness and flexibility, while its weakness is fragmentation and the ability to sideload apps. iOS strength is tight control and a curated ecosystem, while its weakness is that once that control is bypassed through jailbreaking or a 0 day, there's very little standing in the way. Yes? Let me ask you a question. Which platform would you say is more secure? Just think about it. I'll give you some seconds to think over it. The honest answer is that both have real strengths and weaknesses. Hence, your own usage habits matter just as much as the platform. AI in cybersecurity. If mobile security is about protecting individual devices, AI in cybersecurity is about defending at scale. A large organization can generate millions of security events every day, far more than any human team could manually review. This is exactly the kind of problem AI is well suited to solve. Traditional security tools rely on known signatures. If malware isn't already in the database, it won't be caught. Machine learning changes that by learning patterns instead of memorizing examples. First, anomaly detection. Anomaly detection learns what normal looks like, then flags deviation if an employee who always logs in from Mumbai suddenly logs in from another country at 3 a.m. The model flags it without anyone writing a specific rule for that country. Second, classification models. Classification models sort files or emails into categories like malicious or safe. Gmail spam filters are trained on millions of emails to catch scam messages that have never been seen before, based on writing style, links, and sender patterns. Third, speed and scale. Speed and scale matters too. Dark Trace's enterprise immune system monitors network traffic across an entire organization in real time. Fourth, zero-day detection. It means catching brand new malware by watching behavior, not signatures. The WannaCry ransomware in 2017 spread through a vulnerability signature-based antivirus had never seen. But behavior-based system watching for rapid mass file encryption can catch this kind of attack regardless. Let's have a demo for anomaly detection. Yeah, so we can have anomaly detection demo on Google Colab. So let's just start. Now let's just create a data, hour of day and session duration in minutes. Okay. Mm, Let's just take some random values. Let's say I'll be taking 9, 10, 9, 11, 10, again 9, 10, and 3. Your last entry is 3 a.m. login. Okay. And let's do duration. Say 15, 20. Duration is in minutes. Okay. 18, 22, 19, 17, 21, and 2. So here last entry is 2 minutes. That is a very short session. Let's just select model. Now here I have imported pandas from sklearn and all for data manipulation and isolation forest from scikit-learn for anomaly detection. And I have created this data with time duration and R. Now, now you can see I have used isolation forest algorithm. This algorithm works by randomly partitioning, that is splitting the data, because anomalies are rare and different. They get isolated very quickly with fewer splits than normal data points. And here contamination equals to 0.15. This is a crucial parameter. It tells the model that I expect roughly 15% of my data to be anomalies. Since I have given 8 rows for my data, so model will round this flag to the flag the top two most extreme outliers. Okay. And random state equals to 42 means that it ensures the random split are reproducible so we can get the same result every time we run. Okay. Here I have used this fit model.fit predict. Uh, this means the model learns the patterns of the data fit and immediately decides which rows look normal versus abnormal. So as we have given 0.15 equals to contamination, we have got two flagged anomalies. Yes. And here I have used 1 equals to normal data point and -1 equals to suspicious data point, that is anomaly. Okay. Now here we can see uh, 3 hours at 3 a.m. The time duration was just 2 minutes. So of course this is an anomaly. And then one is at 11 a.m. while the bulk of your data happens around 9 a.m. to 10 a.m. and lasts till 15 to 21 minutes. And This event happened at 3 a.m. and last only 2 minutes. So that's why it sits under uh, anomaly. Okay. Next is this 3 hours, 11 hour and 22 duration anomaly is detected. This is a subtle outlier, like an hour of 11 and a duration of 22 are both the highest values in the normal group, because since we want 15% of the data as anomalies, which meant picking 2 points. So it isolated this row next because it sits on the outer edge of the main data cluster. Okay. So now let's get back to our slide. Let's have one more on phishing email classifier. We'll be using naive-Bayes theorem. Come on, so let's do that. Yeah, I'll be taking new file. So here for that I'll be requiring a data set. So let's have data set. Okay. Let's just download it. It's zip file. Okay. So we will first extract this zip file and then we will upload it on Colab. Let's just upload a file. We have uploaded the file. Now let's start. Enable plain tests. Now let's understand what happened. This is a text classification machine learning pipeline that uses a highly effective algorithm for NLP language processing, that is naive-Bayes theorem. So here, pd.read CSV loads our data set we have loaded here spam.csv. CSV is a comma separated file, and encoding Latin 1 is used because text data often contains special characters that default UTF-8 encoding can't read. Here V2 and V1 in this specific data set, V2 contains actual raw text messages. See, you can just read. V2 contains actual raw text messages and V1 contains the labels. Okay, spam or not, you can see. And I have splitted our data set into 80 is to 20 ratio. 80% of the data is used for training and 20% is kept for the testing purpose. So that 20% data is kept hidden. Next, like our computers don't understand these words, so I have used counter vectorizer. This means it converts text into matrix of token counts. It looks at every single unique words across your entire training data set and creates a massive vocabulary list. And this fit transform extrain means two things happen here. It learns the vocabulary and then converts the raw text messages into columns of numbers representing word counts. That is transform. Okay. And transform X test means we only transform the test data using the vocabulary model already learned from the training data. This ensures a fair test. Next, let's come to our training of the model. Here I have used multinomial NB. This initializes multinomial naive-based classifier. It is a probabilistic algorithm based on Bayes' theorem. And here we see model dot fit. I have used the model looks at the word counts, that is X train vector, alongside their known labels Y train, and learns which words heavily correlate with spam like want, free, urgent, and which ones correlate with ham. And then is our evaluation and prediction stage. That is, we have written print accuracy on held out test messages. So here, model dot score predicts labels for 20% of unseen test data and compares its guesses against the actual truth, that is Y test. And for the message, congratulations, you have won a trip to Hawaii. Hawaii, yes. This message doesn't exist in our data set. It is a new message just to test our model. I have used same vectorizer for it, and model evaluated the mathematical probability of this sentence and returned its final verdict. Okay. And here, the accuracy of the message is 98.4%. Like, and this is spam message. We got that. So let's get back to our slide. Yeah, so let's continue. AI based security solution. AI isn't just a detection add on anymore, it's embedded into complete security platforms that both detect and respond automatically. AI powered IDs and IPS systems adapt their rules automatically as new attack patterns emerge. Automated phishing filters like Gmails block the vast majority of phishing emails and well over 99% before they ever reach an inbox. SOAR platforms, security, orchestration, automation, and response. It handles routine incidents automatically. A platform like Palo Alto Cortex XOR can isolate an infected laptop the moment ransomware like behavior is detected within seconds rather than the hours a human might take. And predictive threat intelligence platform like Recorded Future use AI to scan the dark web and forecast which vulnerabilities attackers are likely to target next. Let's move further. Behavioral analytics. Behavior analytics is about understanding what normal looks like for a specific person or account. So anything unusual stands out immediately. AI builds a baseline of normal behavior over time. Your bank learns your typical transaction size. A sudden large transaction from an unfamiliar location gets flagged. UEBA, that is user and entity behavior analytics. It extends this to devices and systems across an organization inside threat detection flags, accounts acting outside their established pattern, like an employee about to resign, suddenly downloading files they have never accessed with. And continuous authentication keeps verifying identity throughout a session. That is, some banking apps quietly analyze how you type or swipe and can trigger re-verification mid-session if the pattern suddenly changes. Now let's have a demo regarding behavior analytics. We'll be doing this also on Google Colab. Let's go to Colab. Here, we'll be having a visual version of what UEAP tools do, like it plots a user's normal behavior and baseline. So let's do it. Yes, let's start. Let's say ours equal to just I'm be taking random values as last time we did 9, 10, 9, 11, 10, 10, 9, 11, and 2. Yes, and say amounts equal to 800, 1200, 950, 600, 1100, 900, 8,000. These are the amount for transaction, okay. Let's choose color. Now let's plot. Yes, so we got the graph. User behavior baseline versus one outlier event. Okay. Now let's understand what we have done. Firstly, we have imported matplotlib. It's the library to visualize data points and identify an anomaly, that is outlier in user activity. and we have used R's and amounts. This represents two variables being analyzed. R's tracks the time of day on a 24-hour scale and the transaction took place. Amounts tracks how much money in INR was transacted. Okay, and I have used colors. This combination creates a list of 10 colors. The first nine data points are assigned to a teal color, and while the 10th data point is assigned a brown burnt orange color to flag it is as the outlier. Okay, see, you can see this is flagged as outlier, and these are normal. Okay, and I have used plot.scatter. This function is used to plot the data on a two-dimensional grid where S equals to 120 increases the size of the dots to make them highly visible. And I have used plt.x label, plt.y label, and plt.title that adds clear textual contents to x-axis, y-axis, and overall graph. See, you can see that plot.x label login are here, y label is here. Yes, and the title you can see over here. So this is the scatter plot we have got, and the user typically transacts during normal waking or business hours, specifically between 9 a.m. to 11 a.m. You can see it over here, and that you can see in x-axis as well. Now, the transaction amount, the values are very low and consistent, ranging from roughly between, I guess, the least one is 600 to 1200. Okay, so you can see that. But the highest transaction is of 50,000 C. Because these points have very similar coordinates, they heavily overlap at the bottom right. You can see that forming a tight predictable cluster. Now, the transaction that occurs at 2 a.m., it's of 50,000, which you can see this brown point, and it sits completely isolated in the top left corner, far away from the baseline cluster. So, in financial fraud detection or cybersecurity, this visualization is a classic example for customer user behavior or anomaly detection. By plotting this baseline behavior, the system can instantly flag the 2 a.m. 50,000 transaction as a high risk outlier that deviates significantly in both timing and magnitude. So now let's get back to our slide. Future trends like AI in cybersecurity is still evolving fast, and this isn't a one-sided race. Attackers are adopting AI too. Yes. So the first one is adversarial AI. It means attackers using AI to craft more convincing malware, phishing, or even fake audio. In 2019, criminals used AI generated deepfake audio mimicking a company's CEO voice to trick an employee into wiring roughly $243,000 to a fraudulent account. Yes. Second is explainable AI, also known as XAI, is about AI security decisions being verifiable by humans rather than a black box. Regulations like GDPR already push in this direction. Next is third is zero trust plus AI. It means no device or user is trusted by default. Even inside the company network, Google's internal Beyond God model was one of the earliest large scale implementations of this idea. Fourth is self healing systems. It can detect, contain, and automatically fix a breach with little human intervention. Some modern platforms can quarantine a compromised device and roll back malicious changes within seconds. Let's move further. Yeah, so key takeaways. Let's wrap up the session. Let's connect everything what we did since so far. On mobile security, Android and iOS both use sandboxing but enforce it very differently. The threats are malware, phishing, network attacks, data leakage. These are common to both, and thorough testing before release catches many issues early. On AI, machine learning detects threats by recognizing patterns instead of only matching known signatures. AI now powers entire security platforms from detection to automated response, and behavioral analytics plus zero trust thinking are shaping the next generation of defense. The common thread is our devices and attackers both get smarter, our defenses have to get smarter too. Thank you, guys. Now we have covered a lot of ground from how your phone protects itself to the threats it faces to how AI is reshaping cyber defense at scale. Okay, so now if you have any queries, you can reach out us at biotechrebion@gmail.com. Thank you.